Okay, welcome to Learn Robotics and AI. And I've started doing podcasts again, the podcast which I used to do a couple of years ago. And the very first guest for the new podcast, Learn Robotics and AI podcast, which was previously called the Building Culture podcast, is someone who has several years of experience working with drones and, in particular, micro aerial vehicles. She actually did her bachelor's, master's, and PhD at TU Delft, where her focus was primarily on drones or quadrotors. And I'm looking forward to having a really interesting conversation about drones and getting to know her journey, how she got started with robotic software development, especially with regards to programming drones and exciting things about micro aerial vehicles. Why do we even care about building these small scale drones? So, a very warm welcome, Kimberly. A pleasure having you on the podcast.
Yeah, and welcome for inviting me to this new revived podcast.
Yeah, awesome to have you. As I mentioned before the podcast, that I was trying to organize this podcast with you a couple of years ago, but then I stopped doing the podcast, and now I'm starting, and you're the first guest. Here. So I think we can just start with your talking about your overall journey. So maybe you could give a short introduction about yourself. You are working as a robotics engineer at bitcraze, right? Could you tell a little bit about your current role and how you got to that?
Yeah, of course. So I am, yeah, as you said, like a robotics engineer at bitcraze, and bitcraze is the company that designs and develops the Crazyfly drone, which is a very tiny drone. Like for, I guess, for the people that can see the video, there's one right here. It's very tiny, and it's a small quadcopter that's being used for both education and research, mostly within the university courses or PhD. I used to use them for my own PhD research back in the day as well, so I can tell you more about that. So what my current role is that I'm focusing more on like robotic integration, focusing on like better ways for researchers to interface with the Crazyfly to be able to do their work. So I'm busy with a lot of like simulation, ROS2. I'm definitely also kind of working with a um, community-driven ROS2 package called Crazy Swarm 2. Actually, last week I was at the RSS, like the Robotic Sciences Systems Conference in Delft, and there we also had an workshop about aerial swarm tools and applications. So there's also a couple of people that maintain their ROS2 packages, which also support the Crazyfly as well. So that's kind of like a bit of a ballpark. So I'm also a lot of contact with the developer community of Bitcraze as well. So yeah, that's my current role. Um, Before that, at Bitcraze, I was more of like an embedded software engineer in the first couple of years, but I kind of transitioned about 2 years ago, around the time that I actually started attending Roscon Kyoto.
Oh,
Very nice
wow.
T-shirt. So yeah, and that's kind of like a little bit and a half year before that I started to get back into ROS and yeah, seeing like what kind of capabilities you can do with it and what extra
Yeah.
capabilities I can give the Crazy Fly, the small guy, give it the power of ROS in order to do actual
Hmm.
robotic stuff, right?
Robotic software development. Yeah, that's a very interesting journey. So I think what I'm also curious to know about is, first of all, I think what is interesting is that you used these drones as part of your researcher role, and now you are basically a bridge between research and basically the industry or the company that you're working in. And also what I noticed based on a little bit of research is that this is a pretty small startup in Sweden, right? So it's like about 10 to 15 colleagues that are working there, or how many people are there currently at the moment?
Yeah, we are currently with only 7 people.
Okay, okay,
So it's definitely a small company. A startup. Technically, we're not a startup anymore. It's
okay.
like Bitcoin has been around for almost like 12, 13 years.
Hmm.
Um,
Yeah, that's also
but
is
mm,
something that's quite surprising, right? So you deliberately want to stay lean because you have the right sort of people that would get the job done, and you do not want to expand probably to really more employees, right?
yeah, it kind of depends. Like we have a bit of a slow growth because all of our income from BitCraze comes from sales, and it has always been like that. There was no venture capital from the start, which also gives us a lot of freedom to be able to kind of really tailor to our users and not to stakeholders. Yeah, what comes with that is also a bit of a slow growth, but we've also been able to maintain. At least the size that we have is that we would like that we're optimizing everything in sense of production of how we also do like shipping and like packing and shipping at at our own
Hmm.
office as well, so we've optimized that too, and of course like the continuous integration of the Crazify development, and then we also support a lot of like a very big ecosystem with the expansion decks as well, and those are also kind of considered products, so we have a lot of products
Yeah.
per person if you kind of count it like that. But until now, like we've been able to do like things like in a very lean and natural way, so that, and also kind of like automate what can be optimized, like automated. So yeah, but like we're still hoping to grow a little bit more. Like the more people we have, the more cool things we can do. But we just hired two new people. So that is hopefully there will be more in the near future, as long as people
Okay.
keep buying, of course.
Yeah, that's obviously. I think the price is also affordable, and I think that's why a lot of research institutes are using it. I think it was. I mean, there are probably multiple variants, but the one that I saw was around 200 to $300. So I think a lot of research institutes can afford to have multiple copies of these drones and really do some try some swarm algorithms or some interesting motion planning approaches. So I think one thing that I'm also curious about is I think based on the size of the company and your profile, which is robotics engineer. So is it primarily robotics software development, or do you also work on a little bit on embedded systems or electronics and mechanical, or are you primarily focused on software?
I would say it's a bit of a 50-50. Maybe the focus is a little bit more on hardware design.
Ah, I
Because like
see.
by foremost, we're a hardware company. So like we develop the hardware, that is kind of where our income's from. So we see kind of the software as well, or the capabilities of it as marketing.
Hmm.
Of course, like there are like we are definitely aware, so like there were or are cheaper commercial drones out there that people can of course also use. But the problem with those are of course are is that the software there is completely closed source of like a couple of most of them that were very cheap. Um, and I guess that is kind of the main selling point of the Crazy Fly, is that people are able to change the firmware to on every level possible, like from controlling the motors directly up all the way to like full blown onboard autonomy or offboard autonomy or swarming
Hmm.
autonomy. So there's a lot of capabilities to use it for. So in a sense, like in the beginning of bitcraze, it was mostly hardware, let's say, with some capabilities, and that has like the autonomy levels within the Crazy Fly has grown and grown, and by additions by mostly also like the users of the community has really driven the software. So we have a really nice ecosystem of software package that comes with it. So it's
Hmm.
yeah, like it's still a cheap price, but some people might think it's a little bit on the high side as well, but you
Hmm.
do get a lot back, let's say, at least
Yeah.
as a researcher.
Yeah, that's very interesting. So I think building the hardware would also be a very challenging thing to do, right? Because you want to keep it within a specific, size, or you cannot keep it larger than a specific set of dimensions, and that means you cannot accommodate a lot of different sensors or components onto it. So what are the challenges that you face, as part of maybe the hardware side of this drone development?
Well, that's a good question, and I think that that kind of goes back to the fact that aerial robotics. This is a fundamental problem that aerial robotics is dealing with, is that ground robots have they have the luxury of carrying a lot with them, especially if they're a little bit bigger, maybe for like even a full computer. Things with propellers when that need to stay in the air don't have that luxury at all. So you really need to be conservative in what kind of sensing do you need, what kind of computing power does it need, whatever power it draws, because whatever power it draws, you take away from the battery life and how long it can stay in the air. So that is an aerial robotics problem in general. For
Hmm.
the crazy flights, it's even more yeah, challenging because it's so small. It's only 30 grams in weight, and it can carry about up to 10 grams more, but that of course will eat away a lot from, like, for instance, that the 7-minute flight time that we have, then suddenly you can only have 3 minutes of flight time.
Hmm.
So it's kind of poses a challenge, like what is the absolute minimal necessary for you to actually have an autonomous vehicle or small autonomous vehicle, and also something that I had to deal with during my PhD, and other researchers also have to deal. Um, so our solution, at least, or at least like the solution that we kind of provide, is that we let the user to kind of decide for themselves which positioning system they want to use, which sensing that they want to use, and then they can kind of plug and play like these. Let's say, yeah, we have these expansion decks um, that they can just take it off and put on something new. For instance, like I have, for instance, here an optical flow deck um, that you can just like put on the bottom, and suddenly you have a different positioning system. So in
So it's
that
very
sense, like,
modular. So the idea is that you could make it work for a lot of different situations and so on.
yeah, exactly. So if you would like to have a drone that's able to fly autonomously in an unknown environment, then
Hmm.
perhaps a flow deck and a motion ranger, or maybe with a camera would do. But if you want to do like swarm coordination and planning control, then perhaps like an external positioning system would be better, with maybe like an ultra wideband that they can communicate with each other. So like it's in that sense, the researchers still need to kind of decide what sensors would be enough, and we do get
Hmm.
a lot of questions like, hey, can it have 4 decks, or can it have this? Like, yeah, sure, but you might have to make some tough decisions, or have to kind of think about, do you really need all that sensing? Or
Hmm.
yeah,
I think
but
it's
that's
pretty
up to them.
challenging. Yeah, I can see how challenging it would be because like different researchers have different topics and ideas that they're working on, and so the demands would be really very diverse. Everyone would have a different set of things that they would require, and that's obviously also the main selling point is that it's really highly modular and you could make it adapt, of course, within certain limits and depending on what are the primary category of researchers you have as your target customers. Yeah. Um, what I also wanted to get to know about was basically your journey of how you got introduced to robotics, because you did your bachelor's at Delft, and then you did your master's, and then you did your PhD. So at what point did you get introduced to drones or robotics in general, and how did you decide that, hey, I would like to continue for 6, 7 years and be working in the domain of drones for a long time.
Yeah, that's yeah, I guess I've had not the most common journey to get into robotics, or maybe it is, I don't
Hmm.
know. Like my bachelor's also at the TU Delft was industrial design engineering. So
Oh, okay.
yeah, so it is definitely also like on the engineering part, but more on like the product design and like making things suitable for the markets, and see what's how you can design a product to be user friendly for the users. So a bit different, let's say. Um, so then I kind of decided that I was perhaps a little bit more interested in biology and engineering. So I wanted to kind of switch to biomechanical engineering. Um, at mechanical engineering. I had to switch to mechanical engineering for a bridging minor. So that's
Hmm.
how I got into that. And once I actually got into the master of biomechanical engineering, I chose the specialization biorobotics,
Okay.
which that's perhaps like a human robot interaction, exoskeletons, like how can you make how can you kind of simulate human movement with robotics, like bio-inspired robotics, let's say. Then actually that specialization kind of came at an end. So there were actually a lot of electives that I can also add to it. So I added a lot of how do you say, artificial intelligence and computer science electives to that.
Hmm.
So that then suddenly then I found that very interesting. Eventually, I think for my master's final project, I was working on a robot with moving eyes. Um, that I kind of put on a platform that was moving like this, and then I did research at the neuroscience department of the University of Erasmus, because I did research for the cerebellum, which is the small
Hmm.
brain. And apparently the cerebellum has a lot of influence on like how I stabilize.
Hmm.
Um, so that was my master's project, was like a cerebellum inspired stabilization system for robotic eyes. Um, then, of course, there was the question of the next step. At that point, robotics, like now robotics super hot, right? So at that point, when I was like when I had to decide between going into industry and going into like stay in academia, um, at that point you only had consultancy jobs. You didn't really had companies that would hire robotics engineers as a permanent job. And in that sense, like yeah,
Hmm.
I kind of still want to do quite a lot in that. And then the opportunity opened up at the aerospace engineering. So that was my third faculty that I went to. Um, at the micro aero vehicle lab, there was a project about having a swarm of pocket drones be able to do autonomous indoor exploration. So that's then I went from like a robotic eye head stabilizing, and went to drones. Yeah, and that switch was quite like it was quite a different field, like going into like something that was more bio inspired to like something that's like swarm robotics in the
Hmm.
air. um so that's kind of like when I started my PhD in 2015. That's when I first started with drones. And I definitely had to learn quite a lot. So at that point, yeah, I guess like that's at least I had to also kind of like start from scratch, in the sense of like I first had to make a drone fly by itself based on optical flow. So that was kind of a little bit similar to what I was trying to do with the head, just on the drone
Hmm.
in the
Getting the
air.
basics
Um,
right, getting familiar with the fundamentals and getting comfortable with the drone.
Yeah, exactly. But it was also that I had to really build up the fundamentals as well, because you had drones that were able to fly based on like a mocap or processing system. I had to make them fly based on other information that was only available on board, so based on the camera.
Hmm.
So yeah, and then I had to go from that to swarm that were able to fly autonomously in the building. Um, so there were a lot of steps in between. I don't know if how much time
Yeah.
you have, but I can. But I
Yeah,
like in
but I
sense
get
of
get
sorry.
the picture. But I get the picture. So
Yeah.
you switched from industrial design to mechanical, and then you got interested in bio-inspired design, and from that bio-robotics, and then towards aerospace side of things, and then towards drones
Yeah.
and swarms. So I think that's I mean, it seems like it's a lot of different things, but it's actually heading towards one direction. I think it's also easy to see that because you were like following the interests that you had at that particular time. You know, you were just following the next immediate thing that you were interested in. So I think that does make a lot of logical sense.
hmm
Um,
I do have to say that like the masters that I was following at TU Delft at about that point, that was just a few years before the cognitive robotics master came in. So
oh, so
that is a new master at TU Delft, which I would definitely like. That like if that existed, I would have gone there right away, but
Hmm.
I kind of did the thing is that I kind of assembled my own master in that sense. But like now you actually have a master that called cognitive robotics, which is kind of like a combination of different faculties. But
Yeah, yeah.
just for people
Nowadays,
to know.
there are a lot of masters in robotics and AI coming up, but I think even let's say 4 or 5 years ago, these masters programs did not exist. So I think it was really something one had to figure out by themselves. So that is, I think, really, and I think probably the good part about your course was that you had the opportunity to choose lots of electives, which you took advantage of, right? Otherwise. So, did you also have lots of compulsory modules, or mainly you were free to choose most of the subjects?
No, I think I had about like I said, like the master came to an end that a lot of courses that were mandatory before weren't given anymore. So I actually had a lot of space. I think about like an full like semester full that I could fill in with electives.
Yeah.
But a lot of courses that I had to do was like yeah, well, of course, yeah, human robot interaction design, like a lot of like um human robot motion, like a lot of the standards that you would learn for like manipulation of robotics or something like that, but also like how to system ID the human body as well. Because it was also kind of like surgical robots, for instance, like how would you have the robot react on a human input? How do you do that in a good way? Um, Also, like with autonomous driving, like that is now kind
Hmm.
of the standard with any new car that you have, that it does like adaptive cruise control, lane following. But like how do you do that, right? Like how do you still make sure that the human still stays in control and still is aware of what it's doing? Because technically you can let your hand off, but if something happens, then like how quickly can the human react? So it was really like I guess like really like the simulating biology with robotics, having a human in the loop with robotics. It's like I guess like also the bio inspired part as well. Yeah,
So,
so in that sense, it was for me a very interesting an interesting master.
yeah. Yeah, thanks a lot for sharing that. Yeah, I think so. It was mainly bio-inspired robotics related subjects that you were interested in, and you took all of these and you assembled
Yeah, so like at the
your.
bio inspired robotics part were the mandatory courses in
Ah, I
it.
see. Okay.
So like yeah, those were the mandatory courses. I mostly add a lot of programming courses and artificial intelligence courses to it.
AI
Those
side of
were not
things. Yeah.
mandatory.
Hmm. Hmm, hmm, hmm. Yeah, so I think I also have a few questions related to your current work. So coming back to bitcraze again.
Of course.
Yeah, so you said that you mainly hardware is your product, right? So you work mainly on optimizing your hardware and making it as suitable as possible for the researchers. So what kind of tools do you use, like on a day-to-day basis? Do you also probably do programming and also maybe use mechanical related tools and so on? So if you could share some of the tools that you use on a day-to-day basis at bitcraze.
Yeah, so like at least on the hardware side, there's two tools that we mostly use is KeyCut for I think it was a PCB design and
Mhm.
FreeCut. So like I don't like I don't necessarily use that myself. I used FreeCut before, but I mostly used like for 3D modeling Blender.
So
Um,
free CAD, free CAD you said, or
yeah, yeah.
so
So
it's
that's
like
for like
SolidWorks or CATIA.
yeah,
It's a mechanical.
it's the free version, like the open source version
Okay,
of.
I see.
Um, so like we try to use as much open source tools as possible,
Hmm.
and also kind of like because the Bitcrash kind of also kind of made a scene from like the open source FOSS movement, and yeah, so we try to also kind of like make use of those type of tools. So that is mostly used from the hardware point of view. The firmware is at least like from the Crazy Fly itself is C based,
Hmm.
um, and then the software side on the computer how to program it is Python based.
Python based.
So, but however, we are experimenting with Rust quite a bit. Like we have a
Hmm.
couple of people in within the company that's very passionate about it, and also kind of like experimenting with embedded Rust. Of course, we need to kind of like have a good balance in that, because we have noticed that not a lot of researchers are using the Rust programming language yet. Um, so
So you
yeah,
have to
but
make sure that the tools that you use are also something that the researchers would be comfortable with and so on, so that uh, it would be easy to collaborate, right?
yeah, exactly. It makes it a little bit difficult to really abstract the different layers. Like if they want to implement a new control algorithm, then they would need to kind of like really go into the low level drivers.
Hmm.
So yeah, we do want to kind of like make it flexible for them to choose whatever area they want to change things on, which they do. Um, but yeah, we also have to kind of like see like what we are passionate about in the company itself, and what we really want to kind of try out. The Crazy Fly is also a product from, like, the passions of the founders as well, and a lot of the
Hmm.
decks that we have made it, or like the software implementation or positioning systems, that has also kind of driven from our, like, our interest within a certain technology. And just kind of like, how can we use that for robotics, or how can we use that for the Crazy Fly? um yeah, so that is kind of yeah, so like it's a kind of an interplay of both. And then sometimes one of these types of technologies is also something that suddenly interests the researchers. um like the ultra wideband localization system that we made a while ago, we still see papers coming out of people trying to improve the accuracy, how to do ranging between drones, how to do ranging between a drone and a ground robot. So they're really playing around, like, okay, what can we do to improve it, or what can we do to make it perhaps useful in the wild. So that is kind of
Yeah.
like, it's great to see that even though it's hardware is completely the same, you can still buy software giving it so much more functionality, or yeah, so you can take so much more out of it as well, and than just purely the hardware. So software is also kind of important.
Yeah. So it's like your role is also pretty interdisciplinary, and I mean, you guys also get to try out your own ideas, and it's very creative as far as I can understand. So you work with the mechanical side of things, the design of it, and also electronics programming using CV, and also just general software. So it could be it would be very, very interdisciplinary. Yeah. So I think the other things that I found interesting was that I noticed that you mentioned in one other podcast that a little bit about the drone, that it has a flight controller, and then it also has a companion computer-based controller, and on the companion computer you have these high level algorithms that are being tested, and then on the low level the flight controller you have all these low level control stability modules, all these kinds of things that are there. So could you elaborate a bit on that and how that links with your role at the moment? So what are the things that you are involved with? Are you involved with also integrating these algorithms for stability, altitude control, all these kinds of things as well, or those are already set after years of development and you focus on other developments?
Yes, so I would say that currently I'm perhaps a bit more on the application level, like, trying out demos, trying to improve the way that people can make applications for these crazy fly drones. But of course, there's multiple levels. If you
Hmm.
want, you can just get a bare bone of this crazy fly, just without any decks whatsoever, and then you can just control it by hand, so manual control with a controller. So that is perfectly possible. But of course, the level above that is position and velocity control, which you kind of need a positioning estimate, which can be done by either external positioning system, mocap. We also have lighthouse system, LPS, local positioning system with the ultra wideband. um, or you can do that with like a relative, like, optical flow based
Hmm.
positioning system, similar to what ground robots use, like wheel odometry. Um, drones use optical flow usually for like an. So then you have position and velocity control. So at least it can stay in the sky. It can hover. You can give it a direction, and so that's the next phase. And that is also kind of like there's multiple control loops. For the manual control, it's a little bit less cascaded, let's say, if you look in the PID control. And then of course, like if you want to do it from position and velocity control, they of course you need a little bit more information. On the lower
Hmm.
level, complementary filters are handier. Higher, you want to go to the common and extended common filters. And then we have 3 state estimation filters on the firmware, and by now 5 controllers. So that the users can choose. Although we say like EKF and PID is the most stable. That's what we test almost out. But if, for instance, a researcher has like, hey, I've made this new controller, it looks great, then they can make a pull request to our firmware, and then we kind of test it out if it flies, and it's like, yeah, sure. And then
Ah,
other
okay.
users have like, or other researchers have access to
Hmm.
more controllers. So then you have position and velocity control. If you go above another level, then you have more like trajectory control, like path planning and things like that. So position velocity control, that's usually like, yeah, let's say go to this A and B, or go forward with a certain velocity. Um, Path planning is, for instance, like I want you to, yeah, follow this path, let's say in figure 8 between these points, and it actually generates the, let's say, the waypoints for the position and velocity controller to follow that. So that's kind of like a little bit higher up. So that can either be just passive like path planning, as it's collision avoidance. There's also a module for that inside the firmware on board. So that is kind of the highest level of kind of control, but where you still have to tell the Crazyfly what to do. But like, you don't have to use as many commands the higher up you go, let's say.
Okay.
So here first is like, oh, I want you to do roll and pitch and yaw exactly like this at 100 hertz. Here it's like, okay, I want you to go forwards until I say that you to stop with 10 hertz. Then above is more of like, yeah, fly figure 8. So
Hmm.
yeah.
Okay. So going more top level and more concrete.
Yeah, exactly. So it's kind of like a abstract level. And then above that, then you have the application level, which you can also do on board. But
Hmm.
the researchers can choose if they want to do it off board or on board. Um, yeah, so then you can also kind of like say, hey, I want to have like an onboard state machine that does wall following, for instance. And then while you do that, you kind of maybe stream the footage off board so you can make a map, for instance. So that is also kind of like, that is kind of what I've done during my PhD, and made sure that at least a swarm of these, or a swarm of crazy flies, were able to completely fly by themselves without me having a computer to constantly say, yeah, oh, yeah, now you have to turn right, or now you have to turn left. No, they
Hmm.
did that completely by themselves. So that is the application level, and that is still on board. But however, it would be nice for researchers to also try things off board, to kind of communicate that, connect a ROS node to it, right? Try out all the cool packages that exist already from the community. Um, yeah, and that is also kind of like the end. But then of course you need an external computer for that, unless you want to use micro ROS, and that's also possible. But that is a bit of, if they're not as familiar with embedded software engineering, then doing off-board processing is definitely like a good first step for them to get started on. Um,
Hmm.
so yeah, that's like, there's a lot of layers, and then it's both what you can run on board in terms of autonomy, and what you can run from the computer itself. And then you can kind of decide where the levels is at. Like if you have a swarm, you might not want to send as many commands to each of the crazy flies as many times as you can. So maybe you would like to say to all of them, just take off or
Hmm.
do your thing. um, but if you have only one crazy fly, it might just be fine to have a little more off-board control, because you're able to send it more commands because you don't have a communication bottleneck. Um, yeah. I don't know, like, if that kind of explains, like, the possibilities that people can do with it.
Yeah, that definitely explains it. And I think one other question with this regard is that, so how does this communication happen? I mean, with regards to if it's a swarm related scenario, so do you communicate using ROS as well? I think you also mentioned micro ROS, so you are also using that, and micro ROS is probably specific to uh, drones, or maybe you could also tell a bit about micro rods because don't have too much knowledge about
Oh
that.
yeah, I think I perhaps shared a bit too much information in it. Yeah, MicroROS is actually that is a project that's currently being held by eProsima, which is a company that's focused on the fast RTBS, which is one of the middlewares of ROS. So they also maintain MicroROS as well, and they have also examples where they run it on board of the Crazy Fly,
Mhm.
and they use then so that is there. That's not something that we maintain or we use at a regular basis, but it's definitely out there. So whenever somebody says, oh, it cannot run ROS off board, yes it can.
Okay, so
Micro ROS, but
micro rods.
it's not at least like when we use ROS on a daily basis. It's more that we make a server where we communicate to the crazy flies through a protocol we call CRTP, which is the
Mhm.
which is the crazy fly real time protocol for short. Which is kind of like a protocol with an extra crazy radio that is maybe a little bit closer to, like, Zigbee, or any of those extra modules that are meant for very fast communication. Um, and we're using this because initially people wanted to control it directly with manual control. And anybody that's
Hmm.
flies like first person view racing drones, you want to have as quick communication as possible. You don't want to use Wi-Fi for that,
Yeah.
obviously. So that is currently, at least like for a swarm, that's probably like the fastest communication, at least for the crazy flies that exist right now. But there are also possibilities to communicate with them with a Wi-Fi. Like currently we have the AI deck, but I wouldn't advise it, to be honest, with a swarm, and
Hmm.
especially if you want to show a demo at a conference, like a conference or exhibition where everybody uses the Wi-Fi. No,
Okay.
do not do not use that. But so we are
Hmm.
using the Crazy Radio with the Crazy Fly real-time protocol to communicate with the swarm, and then we have a server, and that's what we connect to ROS.
Okay, so that's the
Yeah,
primary communication
yeah.
framework. Yeah. Yeah, that's very, very interesting. And yeah, and the other thing, so I mean, I have some random keywords that I have from
Hmm.
yeah, so I think so there are some um I think specific flight controllers that are used in the drone, let's say, space. I think could you elaborate on what Ardu pilot is used for, essentially?
Yeah, Autopilot is also like a flight suite for unmanned aerial vehicles. They also use it for, I think, like for rovers or like boats as well, but primarily for UAVs. And
But
technically,
this is
it's
not linked. So you have your own system, right? So this is not.
yeah, we have our own firmware. There's
Hmm.
there's people that have done like an experimental port to Autopilot on the Crazy Fly, so it's definitely possible for smaller systems like this. But we maintain our own firmware called the Crazy Fly firmware. Um,
Okay.
yeah.
Hmm. And that's
So
also open source, I think, right? That's also
yes.
entirely open source.
Yeah, exactly. Um, there's very similar modules that Autopilot is doing. Like, it needs the basics. Like, it needs the sensing. It needs to do something with the sensing, to the state estimation. Like, they most likely also have an extended Kalman filter or an unscented Kalman filter. And then from there, they need the controllers. PID is the most basic, but the PID controller is for linear systems technically. Um, so I would say that they probably have others as well, like the Lee controller or yeah. So, but I'm not super familiar with what Autopilot has to offer, but
Hmm.
I'm pretty sure that at least like I'm a little bit more familiar with the peaks for Autopilot, and they definitely have an extended comment filter as well, and complementary filter, PID, and perhaps also indeed a Lee manager or a Lee controller. But um, yeah,
Yeah. Yeah,
yeah.
so I mean, just to get a sense, I did work a little bit with drones, but my experience was basically limited to doing visual SLAM using a RealSense drone, and that was there was this a RealSense camera on the drone, and it was basically just capturing images continuously and using ROS packages to create a map of the environment. So do you also do use it to create a map of the environment? You probably do. I think I saw some of your demos where you were also using probably G mapping or I don't know, Octomap or some of these packages to create a map of the environment. But I think for the swarm scenarios, you probably do not need to create a map of the environment, right? So obviously it depends on the researcher's research, but in general, how is it used for SLAM or like computer vision mapping and localization sort of things? You mentioned that, I mean, there are Kalman filters and sensor fusion modules there. So
Yeah, it's like I guess like for SLAM, although there are a couple of papers that came out where they did full onboard SLAM, or like at least like we also have a thing called the AI deck where they also kind of did a bit more things on it with an extra chip for extra processing power. So there, it's like
yeah, that's
before I would say onboard SLAM would be a little bit more difficult, but like if you want, there's a couple of papers out there where they've actually done onboard SLAM with a multi-ranger, which is kind of like a mini lidar that has like a range sensor in 4 directions.
mm,
Um, so at least like what I've shown at, for instance, the Robotics Developer Day
yeah.
was just a very simple mapping example where I used the multi-ranger to create a simple occupancy like a grid map within like that you can see in Arvis, and that's of course like with a slam full slam like a lidar, which is way too heavy of course for the crazy fly, then you would have like perhaps a map of the room right away. The crazy fly needs to rotate a bit or fly around a little bit in order to create a
Mhm.
map, but it's definitely possible. I've even flown with it with like the slam toolbox or let's say the like nav2. Although I must say that I had to kind of cut away the localization part, so just the mapping of Slam Toolbox because it's just not optimized for such a sparse lidar.
Hmm.
But researchers have made also off-board SLAM algorithms with just like such a sparse lidar as well. Um, and there have also been researchers that actually put a camera on the Gracefly 2, which was able to do some kind of like yeah, very simple mapping as well, but it's been a couple of years ago, so I'm pretty sure if they try it again, they have more packages to their disposal, or that they are able to detect like depth based on the camera just by the movement. You can kind
Hmm.
of like see where things are with just a single monocular camera. So in the sense of like what I've shown for the Robotics Developer Day, and people were really impressed, but that is kind of like the very basic.
So
It's like
there were these two crazy flies, I think, and you did rotate those, and I think it was the mapping package, and so I think it was kind of creating a little map of
yeah,
the poor area, right?
we're actually three.
Three, yeah,
But
okay.
yeah, but perhaps on the video you saw two. Yeah, no, like I had a couple of demos that I showed. Was indeed like the simple mapper, just with one. Then I had one crazy fly that also had the same multi-ranger that used that for navigation, so it did while following while was mapping. um, then indeed I had the tree that was doing the simple map that I just rotated, and they merged. And then I had another ROS2 node that was made by somebody else that I grabbed in, and I merged those three maps together, which makes a very impressive demo. And I'm very happy that everything went well. Um, but there's definitely like researchers that are doing way more cool stuff with the Crazy Fly so far. So in that sense, like what I've done is definitely not something that I would write a paper about, but it's something that can
But
apparently inspire people that such a
hmm,
small platform is able to even do that in the first
yeah,
place.
yeah. And that's to show that it's capable of doing these things, and of course, then it can be extended to more complex algorithms of some PhD student's topic, you know. So so I think that's the goal, that you want to demonstrate the
Hmm.
capabilities of the drone.
Absolutely. It's a robot too. Like it
Yeah.
can do like almost like almost everything that a ground robot can do, and maybe
Hmm.
even more because they're with a swarm. But I feel at least like the aero robotics community, they know the Crazy Fly quite well and the capabilities, but the rest of the robotic let's say community still needs to be introduced to its awesomeness. So I'm like
So
at least
what do you think? What do you think are the advantages of drones, using drones over other, ground mobile robots or manipulators or other things? Of course, they are used for different settings, but like, what do you think is the primary advantage or primary applications, maybe even for drones in the real world?
in that sense, I think the agility of them, like
And
that
maybe
they're
maybe
able.
to add, sorry, maybe
Sorry.
focusing on the micro aerial drones, because these are also maybe a special subcategory of drones which make it really safe to be used anywhere. And I think there are also like if a drone is above a certain weight, there are also regulations in terms of you cannot operate it everywhere, and these sorts of things. So I think these conditions do not apply to this micro drone, or how is it?
Now, you also have to really think about the category of outdoor drones and indoor drones. There are like on outdoor drones, there are a lot more limitations. The Crazy Fly is definitely built for indoor flights.
Okay.
So most countries don't really even have a regulation, although we do advise people to at least fly with a net. Um,
Hmm.
so in that sense,
But it's still quite safe, right? I mean, I saw you holding it on your palm, and really, yeah. I mean,
yeah,
even when it's flying, even when it's like operational, so even when the motors
yeah,
are on.
like in that sense, like I'm definitely not worried about flying with it. Like I show all my demos, like if I give an online talk live, usually if it's allowed to, and even on the stage without a net. At the
Yeah.
workshop, we showed a couple of Crazy Flies flying when we had some tutorials. Um, so in that sense, yes, absolutely, it's very safe. But if you would compare it to maybe a tiny ground robot, a ground robot, if you want it to stop, let's say it will stop. If you want a
Hmm.
crazy fly or a drone to
Yeah.
stop the motors, it will fall out of the air.
Yeah.
And of
So
course,
that's
propellers, you
an
need to
aspect.
always be careful with your eyes. Uh, but like it's small, it's safe. If it hits your head, it's
Not gonna
yeah.
do too much damage.
No, no, exactly. And why would like drones, like these small drones would be why would that be more interesting than, for instance, like a ground robot of the same size? Um, it's just like the agility, I would say. It's much faster to get somewhere. It's able to, like it doesn't rely on the ground conditions. If there's a hole that can kind of like squeeze into, like for
Hmm.
instance, like search and rescue type of scenarios is where I think a lot of people that use these crazy flies. And I think it was also kind of like the background of my topics, like okay, how can you make something that's able to fly into a collapsed building and see if there's anybody still alive, let's say, as quickly as
Hmm.
possible. So in that sense, and also like the third dimensions, and least like if you would think about swarm robotics, if they want to kind of simulate flocking behavior of like birds
Hmm.
or fish even, let's say, although that's the kind of a different medium that they maneuver in. Then like the really the 3D part of like the aerial robotics really can add an extra benefit to it that 2D robotics just cannot do. Um, so in that sense, yeah, there's a multiple things that makes it so interesting. Next to the fact that yeah, it's really cool to see something flying.
Yeah. Awesome. Yeah, definitely. I mean, drones with these patterns that swarms of drones form, I think they're also always fun to watch. And I mean, they can also be used for entertainment purposes, but also for other practical rescue missions or other applications that you mentioned. So I think maybe we can talk about a typical day in your life. Like, what are the things that you work on? Like, so you wake up and you start working, and then what are the things that you work on? Do you have like some days where you work on the hardware side more, or do you have like separate CAD days or programming? Because it's a lot of stuff, so I want to get a sense of what your typical day looks like.
So I guess like my typical day is let's see, yeah, okay, so today is a Friday, is a fun Friday, so that's a little bit different.
Okay.
But normal when it's not Swedish summer holiday and all the colleagues are at the office. Wake
Hmm.
up, breakfast with my husband, make sure that I get to the office at 9. Sometimes
Hmm.
I'm a little bit late, but another colleague of mine is also because that's when we have our stand-up meeting. So then we have a
Okay.
stand-up board where we kind of
So like
like
you
say,
follow Scrum framework, right?
yeah, we have kind of a Scrum framework. Like bitcraze in general is self-organized as
Hmm.
well, so we have like a flat hierarchy. So we kind of also use like a couple of these Scrum techniques in order to coordinate our work.
Oh.
So then we have like stand-up meetings, like what we have done yesterday, what we're planning to do today. If there's anything important to mention, usually takes about a half an hour. Then usually in the mornings we handle like emails and support, unless it's like a crunch day, then we kind of skip that. So I also help out quite a lot with answering support emails or like having like answering all the support questions on our discussions. But we kind of coordinate like like sometimes somebody else takes it over, sometimes I take it over. It depends on how busy people are. Then usually like in the afternoons, we're going to work on development projects. Currently, we're really working on getting the Crazy Fly brushless, which is a new product that's coming out in the fall. That we have a couple of stories running, let's say. For instance, we want to implement like a better safety system because now it's with brushless motors. Brushless motors on drones are a bit bigger, a bit stronger. So we just have to make sure that there's more safety regulation within the firmware. So then there's multiple people working on that. So that is kind of our typical day. And of course, we have a lot of coffee breaks. Usually, when we go to the coffee break, we kind of talk about new ideas for the future products. Um, but today was a bit special. Today was a Friday, so it's Fun Friday, which is kind
Hmm.
of like you don't necessarily work on the projects that we have discussed during our quarterly meetings, but you work on your own project.
Okay.
Um, so today I actually found today I was working on a special, like there was a nice ESP based Wi-Fi chip with a camera that you can buy Seed Studios, which I ordered, which I kind of wanted to put on a Crazy Fly itself. So then I would, so it's a bit firmware and hardware. Then of course I need to kind of make sure that it streams the footage to the computer, and then I just was checking, okay, what kind of let's say what kind of power requirements does it have? Is it something that the Crazy Fly can actually provide with the battery? Then it's like, okay, I think it will got it almost. Then I'm just going to solder at least that deck to like just the prototyping deck of the Crazy Fly, and then I'm just go. And today I was able to make it fly and see like, hey, the
Oh,
camera
wow.
footage is still working, or the streaming is still working. So, and then you can kind of go from there. So that's at least what I've been working on today, just to kind of try out
So on
somebody
these
else's hardware, like because I'm not. myself a hardware engineer, like, but I like
Mm.
to use cool hardware that other people make, like, and like the Crazy Fly, like, and show its more capabilities, let's say. Um, so yeah, and that's Fun Fridays every Friday, and pretty much a lot of decks or the decks for the Crazy Fly has been developed or started out as a Fun Friday project.
Ah, that's
Um,
very interesting. So
yeah,
everyone can like work on their ideas that they're excited about, and that also eventually contributes to the main, let's say, pipeline.
yeah,
So yeah,
exactly.
interesting. And so maybe coming to the final set of questions. So yeah, so this is open source. I think it is mainly for educational purposes and for research purposes, the platform and also the software firmware and framework, all everything that you're developing. So if there's a student who is an absolute beginner and he wants to start learning programming drones, let's say using ROS and all these different things, Kalman filters. So it can obviously be very overwhelming. And what advice would you give, or what would be your suggestions to really give them a first starting point? Hey, go ahead and check out this open source repository, clone it, play with it. This would really make you familiar with it. Or what are your suggestions?
Um, yeah, like it's of course, as because I work at bitcraze, I would like to promote the Crazy Fly,
Mhm.
of course, is a fun way to actually get started on that, because you
Yeah.
have a lot of these cool courses that start from simulation already with a wheeled robot. Like I've followed the, let's say, it was mobile robots by Ross 2 course by Matt Sadowski from Weekly Robotics, which was a
Ah,
really
okay.
nice
Yeah.
one. Um, but I also would like to kind of add is that, like, robotics is about the
Doing
real
things
thing.
hands-on. Yeah.
So it's like, in that sense, I would definitely recommend people to get a real platform. And if the Crazy Fly happens to be one, like, you put the flow deck on there, you maybe put in like a Wi-Fi camera deck on there, and you can already do quite a bit, as I showed at the Robotics developer day.
Yeah.
Then I would maybe first suggest people to maybe first see like whatever package is supported by that particular platform. Like if in the sense the Crazy Fly would say like, okay, first just get familiar with the Python library. First get it fly, like, make it fly stably, make it fly forward, just get a feel for that from a bit more simpler library, so that you can already kind of get creative with what you can do and what you can
Hmm.
do with the sensing. And then after you've gone by that phase, then like, okay, let's get Ross into the equation,
So step by
because
step.
I would say step by step. So like for us, like for the Crazy Fly, first get to know the Python library, and then try to look into like the Ross packages as well
Yeah.
and the Ross
So
tutorials. And then once you kind of got a feeling for that, of course, like first the Ross 2 beginner tutorials, obviously. I always recommend people going through that, or like a ROS2 beginner tutorial, like from the courses that you provide, or from the one from Open Robotics itself. And then they can use, for instance, like the Crazy Swarm 2 package to actually interface, make the Crazy Fly take off, read out the messages, and then just like, think about what you can do with it. Like the multi-ranger, you can make a scan out of it, and then you can generate a map. But how about maybe not necessarily generating map? How about making a state machine out of behavior trees,
hmm.
right?
So it
So
depends
based on
on
that input,
the
I
interest
haven't done that
and
yet. I would actually
hmm.
like to try it out.
Hmm.
Or
Maybe for the
I
next
just can
Fun Friday.
exactly, yeah. Or for instance, like try to interface a Crazy Fly with the Move It 2, which is made from manipulators, but it's
Yeah.
technically a planning package, like arms or drones. What's the
But is
difference,
it
right?
generally used? Is it still used for drones or move it or generally not, right?
No, I don't see it that often, but I definitely like,
But could be
I think
interesting
I've seen it.
to.
I've seen it at one of the Yeah, like when I was preparing for Robotics Developer Day, which is by the construct, they also had suddenly had a course in there, and it's like planning with Move It. I think one was still was one with a drone. It's like that
Okay.
is brilliant.
Hmm.
However, I did talk with some of the Move It, or not the Move It people, but I think people that had experience with it. It's like, hey, how would it be if you plan for like a swarm to use that package? And like, crazy. Like, why would you do that? It's like, but it's planning. It's trajectory planning, right? Like, yeah. So
Path and trajectory would be a trajectory is a trajectory at the end of the day. It makes sense.
yeah,
Um,
like either it's an arm or it's a drone. So
but
I
you
would
there the
say, yeah,
kinematics would be different, obviously, and everything. So, but it's a path that you're giving as an output. So, yeah, it's
yeah,
an
exactly.
interesting
And in
thing to
in
try.
that sense, like, you can kind of you have the real thing, and it's like, okay, it has its limitations, but what can I do to enhance those limitations by using all of those existing cool ROS2 packages out there, and by actually implementing or making small projects out of that? That is how you and get excited about it. Of course, that is how
Hmm.
you learn.
Excitement is the most important thing.
Yes, absolutely. Yeah, there needs to be a project that you're excited about.
Hmm.
And I think at least robotics excites me the most. Actually seeing something flying and doing something new and learning something new in the process.
Yeah.
That is just, that is just something that you I hope a lot of people that just get started at one point have a chance to experience that.
Yeah. I think
So yeah,
that's the cool thing about robotics is that you program uh, you program something, you write a piece of code, and then you see something happening in the real world. I think that is what is super interesting,
yeah.
right? And that's why everyone who starts into robotics, they just really can't stop because there's always so much to learn and try out. So yeah, that's really so. The other follow-up question on this was so I mean, you of course encourage to work on the actual hardware, and of course on the actual hardware, learning would be the best. But maybe if someone could not really afford to buy a drone or something, so do you think just from gazebo simulation or in a simulation environment, one could really gain a certain set of skills? I mean, the algorithms are the same still, right? So do you think that would still help a student make progress, and then maybe they get an internship or something, and then they can get access to an actual robotic system or a drone? Or do you say, no, you have to buy a crazy fly and work on that?
Oh, like, it's of course for the, like, bitcraze would like to have more people buying crazy flies. This it definitely enhances your experience, but I think you can already
Mhm.
get pretty far by simulation, and not only from crazy fly simulators. There's definitely also for, like you mentioned, AirDoc but PX4, they have really good ROS support as well and full software in the loop. So it
Mhm.
means is that you don't necessarily have to have a real drone in order to already try out their controllers and estimators already. So like you can already start digging into the codes, and then of course, like, you have the code that goes on the firmware and the code that of course like runs on ROS. So you can kind of like try the interplay there. Although I would say eventually it would be nice to try something out on a real robot. And I think that is perhaps also something that hardware companies or so, or drone companies, would see an extra value if you at least had that experience. But just
Mhm.
to build up the skills, it's perhaps not necessary to start right away with with real hardware. You can also kind of first kind of try out those tutorials on simulation alone and see if it's something that you actually like and enjoy to do.
Yeah.
um the hardware enhances the experience mostly. um and also kind of like, and that is just also specifically for aerial robotics. Like, aerial robotics can also be a bit dangerous, so it's actually quite crucial that you actually know what you're doing from the start, by using the simulator first
Hmm.
to try out your trajectories and applications before you try it out on the real thing.
So it's even
That is
preferred.
also very important to take into account. It's like the simulation is not only a learning tool, it's also a safety tool, at least in
Yeah.
aerial robotics.
Hmm.
um, yeah. And also, yeah, I guess like I'm also for air robotics in general. We made with the aerial robotics ROS community group something like a nice website called the Aerial Robotic Landscape, where we just
Okay.
kind of like have a lot of resources for people that want to kind of like get to know about different simulators for aerial robotics, for different firmware, or different educational systems for aerial robotics. Because it's already quite a difficult field of robotics. Like, yeah,
Hmm.
the ground robots, like I said, if you want to stop, it will stop, and aerial, like a UAV will crash. So
Yeah.
it's a little bit less.
Safety is even more critical.
Yeah, let's say in that sense, like it maybe makes people a little bit uneasy to actually start flying with it. So
Hmm.
in that sense, it is a bit of a difficult field to fully get started. Even if you've already done robotics, like I did when I did my PhD, there's still a bit of a gap that you really have to go through. Um, and flying with a small drone, at least, like if it crashes, there's not that much. Um, yeah, it's like it's not too bad. Definitely, these are pretty sturdy.
Hmm.
Especially like the drones that I started out with. Those I didn't start out with the crazy flies, but then it's like you don't want those to crash, or else you'll be soldering
Oh,
them together again. But these at least are pretty sturdy. So yeah, small steps yet again. But yeah, you can get started with. To answer your question, you can definitely get started with simulation. That's
okay. Yeah, that makes a lot of sense. I think, yeah, definitely not just from learning standpoint, but also from safety standpoint, as you mentioned, for specifically for aerial robotics. So, yeah, thanks a lot, Kimberly. I think it was a really great conversation with you, and we got to talk about drones and a lot of different aspects of your work and how students can get started with Crazyfly and open source repositories that they could try out and working with simulation, all these kinds of things. So was a really interesting conversation, and hopefully the students got to learn something from this episode. So thank you very much.